What is computational thinking and how should this be taught? Computational thinking is defined by Wing as building on the power and limits of the computing process. I take this to mean that one must understand how a computer works and then use their own ideas to improve upon the functions already in place. As suggested by barefoot computing, computational thinking does not mean thinking like a computer, only that it allows us to solve problems effectively, regardless of whether or not a computer is available. Barefoot computing also proposed 6 concepts and 5 approaches for computational thinking. The 6 concepts are logic, algorithms, decomposition, patterns, abstraction, and evaluation. Logic requires the thinker to make predictions and analyze the problem. Algorithms are made up of specific rules and steps which must be followed in sequence. Decomposition means breaking the problem down in smaller steps in order to solve a large problem more easily. They must compare their own program with examples to look for patterns to help them work out common features. Abstraction means removing any details which are unnecessary and simplifying more intricate points. Evaluation requires the child to consider what they have discovered so far and make a judgment of the overall process once they have finished. The 5 approaches for computational thinking are tinkering, creating, debugging, persevering, and collaborating. Tinkering allows the thinker to experiment with their project and play around with different ideas. Creating is the next step in which the designing and making of the program take place. The program must be debugged, so the child would have to find and fix any errors which have occurred. Persevering means that even if the child begins to struggle, they must carry on as there will always be a solution. Finally, collaborating requires children to work in pairs in order to create their programs. Jill Denner noticed that children worked differently on their programs depending on whether they worked in pairs or individually. Children working in pairs spent longer than individuals, ensuring that their programs were running smoothly. These children also had to communicate their ideas concisely in a way that their partner would understand, therefore ensuring that they were thinking computationally. Brennan and Resnick state that computational thinking is a broad term which has not fully been defined, and nor have any firm strategies been put in place to assess children's grasp of it. However, they have suggested that the development of design-based activities, such as Scratch, have the ability to support the development of computational thinking in young people. Curzon et al. Suggest a framework for teaching computational thinking, which consists of 4 interconnected stages of development: definition, concept, classroom techniques, and assessment. The first stage merely consists of setting a definition for computational thinking that all children can understand. Stage 2 sets out to define the core concepts involved. However, these differ slightly from those given by barefoot computing, and I prefer the latter as they are much more child-friendly. Classroom techniques also defines the core concepts in computational thinking, but in a way for children to understand more easily. The assessment stage provides a way to assess children's growing competence in computational thinking by splitting up the subject of computing into 3 parts and providing guidance on how to grade children accordingly. Robert Tinker's argument that the key to computational thinking is to break big problems into smaller parts was very helpful in considering how to teach it, and his theory also backed up the views of barefoot computing and Curzon et al. Computational thinking can be used across the curriculum, for example in mathematics when deciding which method would be best for working out a sum, or in drama when working methodically through a script rather than just picking random parts which are enjoyable. The national curriculum states that, among other skills, Key Stage 2 children must be able to design, write and debug programs that accomplish specific goals. This means that they will need to understand both the process through which a computer goes to achieve its final goal and also how they can make this happen.